AI precisely, forgive me. Fundamentals of high performance AI. So before I dabble in, just a quick intro of myself, quite really briefly. My name is Sam Ayo. I'm a senior AI ML engineer and data scientist with a couple of industries experience that I've worked in, and some production systems I've tinkled my hands around across my career. To enrich my experience, I always like to talk about my experience and background in software engineering. It gives me a pivotal leap when it comes to understanding designs and architectures from the software angle, and then my discipline in mathematics and statistics, which gives me an understanding of AI and machine learning around the hood. Okay, that's a bit about myself. Let's go straight to it. So today we'll look at why high performance systems matter, the metrics for high performance. We'll look at the trade-offs that you need to think about. We'll look at performance bottlenecks. We'll discuss around the measures, right, for evaluating performance systems, and then we'll discuss a little bit about parallelism 101, and then we'll look at optimization and model inferencing techniques. So before I move on, again, the way I like my class to run, I like to run a very interactive class. So beyond just using the icons or using the charts, I enjoy a class where there is a bit of auditory communication, where you can unmute your mic and ask questions, right? In between, you can raise your hand and ask questions, and also you can unmute your mic and respond, especially when I have questions. Because for these sessions, it's always very important that you know them, beyond just being able to design things, but to design things that find their way into production. That's what really stands you out from being a coder. Let me use that word, from being a coder to actually being an engineer. All right. So what do you guys think about, why do you think high performance matters when it comes to AI systems? Anyone? You can actually just unmute your mic and answer, and if there's simultaneous mic on mute, the first voice I hear, I give that person the audience. So why do you think high performance systems matter? Again, if you don't respond, I'm going to randomly call you. And if you don't respond after I do that, I will call somebody else and I will call you again and when you listen to this recording, it will be filled with your name. So why do you think high performance matters in AI systems? I think Nimi is unmuted, but I don't think I can hear, except maybe that's an error, but this is showing that you're muted. Or you quickly, were you trying to speak, or that was Victor? It's good, but can you unmute? Give me a bit of auditory communication. I'm not telling you I'm not in a good place. People always say they are not in a good place to meet them every time.
Hello, can you hear me?
Yes, I can hear you, Victor. Good.
Okay, perfect. So yeah, I just meant scalability in the context of, for example, if you are building a product for production level usage, so definitely it's a different case if you're building for dev or on your local, but if you're going to serve it to customers that are going to use, and maybe, for example, to a region, to a company, then it has to work as expected to deliver what you say it would and as reliable as possible. So that's what I meant by scalability for large amount of users.
Awesome. So Victor, stay on. Let me engage you for a while. All right.
Okay.
Give me 2 examples of companies who you believe have done this and have succeeded, one internationally and one locally.
Okay, so I think I'll just go with maybe very common OpenAI ChatGPT we use every day. So for example, we interact with that regularly, and numerous millions of users writing different prompts at almost the same time and expecting result almost like immediately. And secondly, locally, just think of all the banks or fintechs where you make payments like OPay or any of these fintechs where you make a transfer and you expect that immediately you get a response, a success or fail. So in all those things, there are a lot of systems that are going in place to ensure that all these are working perfectly. Yeah.
All right, great. So let me engage a bit on. Don't worry. If there's anybody that also want to communicate, just raise your hand. Right. If you want to join in the conversation, raise your hand. But I want to touch more on this, right, to steer the conversation. So let me just put a bit of context, right? I like what you said, Victor. I really enjoy that. Okay, just a bit of context to the banking team, right? Since you mentioned OP, some few weeks ago, I was reading through Twitter and I X, right? And I saw a tweet by someone who was asking a very, very interesting question. The question the person was asking is, traditional banks, when you do transactions, sometimes it delays, sometimes it responds, but it's never as fast as OPay. Let's use OPay now. Never as fast as OPay. So everyone kept asking, what is OPay doing differently in terms of infrastructure that banks find it so difficult, or traditional banks, OPay is commercial, traditional banks find it so difficult that they cannot adopt to level the playing field? And a lot of people were commenting. Then some said, okay, Solomon, just hold on. You buying. Okay, you know what? Let me pause there. Solomon, buying. Let's see.
All right. On what you just said, right? I feel like when you are building AI systems and you're deploying in solutions, right, in production, four things are very important. Number one, what you're building, is it maintainable? Is it accessible? Is it reliable? And is it scalable? So I believe that some of these companies that are really scaled higher, like Amazon and OPay, that give very low latency, right? The thing is that if, let's say, initially they built one model for a particular purpose, when the time comes when they need to kind of build, like, say, 10 more models to upgrade things, they do it in a parallel way that becomes easier, and then it kind of reduces latency, like the period of time that people get response, right? So what I feel is that when some other companies are building solutions, they don't take account of building something that is scalable, that can be retained, that can be easily accessed and maintained. That's what I think.
Awesome. All right. Beautiful. Okay, so Victor, let's come back to you since you broke the ice, right? Again, if anyone wants to contribute, feel free to just raise your hand, and of course I'll pass the mic to you. All right, so Victor, right? So I was reading this. This thread. A lot of people were saying a lot of things, which is part of what Solomon said was mentioned, right? And then someone said the whole thing about OPay and the likes is not really an infrastructure solution that is solved. That what they did was they have like a reserve, a cash reserve that is put at allocation, perhaps every cyclical period, right? And when you make a transaction, they balance the books. That is, they credit the receiving party from their own cash reserve in hopes that when the target bank, say you are transferring money from OPay to Zenith Bank, right? The catch there is that the person with the Zenith Bank card is supposed to be credited while OPay gets debited. But what OPay does is that they don't wait for Zenith Bank to balance up and credit the person. They credit the person on behalf of Zenith Bank. And then when Zenith Bank balances up, then they use that to be a replacement on the reserve, which they pull money from to balance the user. All right, so the dynamics is actually a bit kind of interesting and also intriguing and also scary at the same time, but it gives a bit of perspective of innovation is multidimensional, right? And again, innovation is perspective, in terms of perspective, and that's really interesting. Okay, so now back to the discussion we're actually baselining on. No, Solomon, Victor, don't meet here, but we're still in your discussion.
Okay, sure.
On high performance systems. All right, so you've mentioned the financial systems, right? And then you've also mentioned, which other one did you mention?
OpenAI, like
OpenAI, exactly. All right, so let's talk a bit more. What do you think OpenAI is doing that is scaling performance? Because if you recall, right, at the initial few launches of successive models in OpenAI, they suffered a lot from server crash. There were times that say OpenAI, the server is down, server is down, server is down, right? So what did you think that they did that moved them from a performing system to a very performing system? What do you think they did?
I mean, just off my head, I would say for one, definitely it would have to do with how the processing would occur. So maybe, for example, things like load balancing when so depend where it automatically switches based on different requests. So where the whatever like the processes are happening in parallel, and then there is load balancing to ensure that everything uh, it's scalable. Then also we could look at, I believe that they must have also optimized AI architecture. So like, for example, the transformer based like the transformer based AI ecosystem somehow optimized for only using what needs to be run per time, so there isn't enough load when it's not needed. So I'll say more of parallel running and distributed systems for different usage and demand. Yeah.
All right, great. Okay. Thank you, Victor. Thank you so much. I mean, you can meet your mark. That was a beautiful one. Thank you. All right. I don't know if this raised hand is Solomon's older one or is it recent when he wants to speak.
No, it's the older one.
Okay, please just lower your hand so that I can get to understand. All right, Ido, go ahead.
Okay, so I think in terms of performance, I'm not sure what OpenAI is doing. But, at a point in time, I had that issue too. So I came across asynchronous architecture and concurrency. So the system can be concurrent and at the same time parallel. So if it's just parallel, there's going to be an issue because you want to probably be using multiple cores in the server. So, but if it is concurrent, it definitely means that probably it's not input and output blocking, which means that a user is not blocking another user from interacting with the system. So, and also DB operations, that database operation should not be synchronous, which means that if I'm operating on, if the system is attending to me and then maybe performing a DB operation, it wouldn't affect another user. So automatically, multiple users can be using the system and one is not going to block the other. Even if the infrastructure is overwhelmed, it will still be attending to all the users concurrent. That's my own view.
Awesome, thank you. Now you've unlocked a different. Are we going to leave this agenda slide because we keep unlocking new things as we go, which is really interesting. Akin, I need you to contribute, right? But I need you to contribute in this light. Akin, can you hear me?
I can show him. Yes.
Yes, sure. Yes. Is there another Akin in this call?
Okay.
No, there's only one Akin here.
Okay.
Are you looking for Akin second connection? I think that's what LinkedIn calls it, right? Third connection, second connection.
Well done, sir. Thank you, sir.
All right. Good evening. All right. So after that, I think Chirag, I would like to ask you the next one. So I just want to let's keep the conversation on the round table. So it always just spoke about something that's really interesting about concurrency and parallelism, right? And I always like engineers to think on this direction because whether you say, "Oh, I'm not a software engineer, I'm an ML engineer, I'm an AI engineer," if you don't really understand how these things work, you will struggle, right? You will struggle to be able to build edge case systems. So it's not a software engineering thing. Right? It's an engineering thing for all engineers to understand, especially when you're not an AI software engineer, right? When you are an AI engineer or an ML engineer. All right. So he spoke something that really drove the conversation again on performance to about these conditions, right? Where one user is trying to write to the DB, another user is also trying to write to the DB, and they are doing it at the same time. All right, that's one leg, right? Then the other leg is two people are querying the same system at the same time, and this system needs to respond to two of them simultaneously in a way whereby one must not block the other. In your own opinion, Akin, how do you think such kind of system can benefit from high performance, and why does high performance matter to such kind of a system?
Wow. My view, I'm not so well grounded on these things, but I imagine
sorry, before you continue, I know, and I'm not expecting you to give me a PhD answer. I expect your opinion, right? Because that's what matters the most.
Okay, sir. Thank you, sir. So my perspective would be that in scaling use, so that there are more people coming can use concurrently, and like I said, the processing is expanded. The processing abilities of the system processing can be extended and expanded and all that. I remember I have a little bit of Oracle background. I remember Oracle has this thing about the locking transactions, and then making sure that as somebody is querying here, and then they put in a cache, and then they make sure that the results are also accessible to the next another person they're coming in. And well, sir, let me be frank with you. I'm a bit out of my depth on this for now. Please, I beg you, sir. I just I'm a bit
the funny part of it is you spoke right on cue. Right. You spoke right on cue. That's the funny part of it, that you think that, oh, you're out of line, but you're actually, should I say online? You're actually online, right?
Wow.
Okay, Solomon, go. Yes, Solomon, can you hear me?
Okay,
all right,
yeah.
yeah.
I was just I was in transit today, right? So I was reading this material that Dr. Zion dropped on machine learning systems. So the author of that book mentioned that the company that he was working for at the time had about I think 8,000 users then, and what they did to increase performance of the system was that for users to be able to have responses on time, they had to build 8,000 models for 8,000 users. That's all I have to say.
You guys keep taking. Do you don't want us to leave this particular slide? Because you're provoking thought in my head, right? You're provoking thought in my head, and as far as I'm concerned, actually, if this discussion we are having is enough to provoke thought in everybody's head, to make you read more, study more, learn more, I think I'm satisfied for tonight. So what you mentioned is something I was planning to teach. I think later on in the course we'll touch on it. Model 7, many to one, right, and one to one. So some systems, right, when it comes to designing model 7, right, for different domain and different businesses, there are certain problems you will face, right, that you would at a particular time have to design a one-to-one model 7, right, for users. And then you would also need to design a one-to-many. So what one-to-many means, you have one model is serving what material is that about? Okay, I think Solomon will help you with that. So you come to a situation where you have like one model, and then that one model is serving all your customers, right? Every single customer, one model is serving them. And then there are situations where you come into, and then one model cannot serve all your customers, right? You would have to build a single model that is tailored to each customer. Now, this single customer is not a single end user. It may be B2B, right? It might be B2B, where your business is servicing another business. Do you understand? So you might find it in that line. So that gives a lot of scope to what you're actually talking about. All right, I said I wanted to hear from Chirag before I move on. Yeah, so Chirag, what do you think about high performance systems and how it matters to AI systems? Is Chirag on the call? Can Chirag hear me? Okay, I don't think he or she can hear me. I want to call somebody I've never called before that might even be a very strange name. Sarah looks a bit, yeah, I don't think I've spoken with Sarah before. Hello, Sarah. Hi, can you hear me? I don't want to believe that Sarah is in this call and or maybe she cannot unmute her mic or something, or maybe she sent her AI to join this call ahead of her. All right, so while we're waiting for that, Uduak, can you hear me? Maybe tonight I will do women in AI. I'll just target all the ladies and just call them specifically. That's interesting. Oluwapemi, oh yeah, Oluwapemi, can you hear me? No, they've not said it. Who told you they've said everything?
Hi. Yes, I can hear you.
Yes. All right. So you know what? Let's make it a bit very simple. Although I plan not to make it any simple, but just contribute to the conversation so far. I'm not asking for PhD level, right? I'm just asking for your own opinion.
Okay. Well, in my little knowledge, I think high performance is needed at production scale because in terms of handling enormous data, if your system does not have high performance incorporated in it, I think there's going to be flaw in the products that you're selling, and you'll be giving your users headache. So in my own opinion, I think in handling big data, big consumer base, high performance is needed. So I think that's my only two contributions to what everybody's saying. Thank you.
Okay, no, please stay on the call, Oluwapemi. Let's talk about why it matters just a bit more. Out of these companies, I'm sure you can identify, if not all of them, at least a very good percentage of them, right? You can identify. Okay, just tell me how many of them can you identify? Let me not assume for you.
Okay, there is an app I have on my phone. I think it's a popular one. Shazam.
No. Can you see my slide?
Oh, okay. Yes, I can see
Okay.
it slide.
All right. So identify these apps for me, and where you think, which industry you think they play with.
Okay, I can see TikTok, ChatGPT, Tesla, Netflix. I don't know the last one way more. So
Right.
for ChatGPT, for instance, I mean, you can imagine millions of people that are asking ChatGPT questions at the same time, right? If the OpenAI company don't have, I mean, if they didn't factor high performance in the development of their models, I think there's going to be lag, latency and all of those to some persons. Some persons will be experiencing serious lagging in getting their, responses, while some will just, might work out fine for them. So, I mean, that's what I can just wrap my head around.
Okay, thank you so much, Oluwapemi. That's cool. Uduak, this is the time to say what nobody has said. Nobody has said anything here now. Only Oluwapemi has said something. She has mentioned OpenAI. So out of the others, which one can you speak to, and how do you think, in your own opinion, that they have implemented high performance?
Okay, confirm you can hear me.
Loud and clear.
Alright, maybe I'll speak to OpenAI,
No, somebody
ChatGPT.
has spoken about OpenAI.
Okay, which other one? Oh,
Don't you watch Netflix?
okay, I do.
Uh-huh.
Okay, Netflix recommendation. You have millions of users, so I would definitely not expect I would definitely not expect it to be slow. So definitely it should. We expect high performance. Yes, that's it. That's from my end. Thank you.
That your end is very short. That your end must be a very short end.
Like I mean that like the system must perform well because you have millions of users. Like the whole Netflix recommendation system. Like I don't expect the system to be slow. So that should probably be a reason why.
The way you say I don't expect, you must be a very difficult customer.
Ah, okay. I have spoken. I don't know why Zion is laughing right now.
All right, Nimi is coming in
Okay.
as Matrix. She's coming in as Neo, the one. Nimi, go ahead. Go ahead. Don't introduce your hand again. We've been waiting for you. Can anyone hear? I don't think I can. Nimi, if you're speaking, I can't hear you. I hope it's not my network, and I hope it's not my sound at the same time. So, Nimi, if you can hear me, I don't think I can hear you. What you can do is confirm that if you're using an headset or something, that you disconnect it and reconnect it back. And if it still doesn't work, just leave the call and come back in, but be very fast, like leave and come back, like in a flash. Yeah. So you can just leave and come back in a flash, and then let's see. So we'll buy you some few minutes, just very small few minutes, maybe 1 or 2 minutes to leave and come back. All right. I want to see. I don't want to lose. Okay, I don't want to lose. Okay. In the meantime, right? Can anybody speak? No, not. Let me not use anybody. I want to pick myself. Right. Nimi, if you believe your sound works now, you can unmute and let's try it. Because your hand is still raised. Except maybe, that might just be. Yeah, there's another woman in tech here. Alimat. Hello, Alimat, can you hear me? Hello? Okay. All right, maybe I should just move on from here. I don't know if Nimi has left. I don't know if, okay, I think she's still here. Okay, she left and she has joined back. Great. So just unmute your mic, Nimi, and let me see if your sound now works. Nimi, if you can hear me, you can unmute now. I don't want to believe it's your village people.
Okay.
Working
Sorry
hard.
for the delay. Can everyone hear me now?
Yes, I can hear you. I can hear you now. Great.
Okay. So I was saying, sorry for the delay. I was saying that for Netflix, aside the prediction of movies and all, the database that stores the movies itself and calling each movie as users are viewing and all would require a lot of would require high performance, as it said, and that's one where I feel like Netflix has really succeeded, because having so many users at the same time watching several movies and calling up several movies from the database would require that the system can carry all of those things and execute all of those functions.
Awesome. That's cool. Thank you, Nimi, for sharing. I think Olawumi raised the hand earlier. If you have something, let's just see if that chips in. If not, let me just move on. Olami, were you trying to say something before?
Yes, I was trying to speak to Tesla, like in terms of efficiency and speed.
I'd like, oh yeah, you have the mic. Elon Musk, Elon Musk.
Like in terms of the speed and efficiency. So that was what came to my mind. Like looking at the speed and efficiency, it's a real-time application. So speed and efficiency really matters. So
how do you think Tesla works? Just off your head. Like, I'm not asking again, guys, I'm not asking for PhD level. I just like to incite thoughts in your head. How do you think Tesla works?
I mean, he has different things powering it, talking about the computer vision and all of the. That's what's coming to mind. I'm not an engineer.
You're not an engineer, but you're in engineering class. I
also think that they do it. There's a lot of this because of cloud technology now. There's a way you can use cloud technology with this orchestration and Docker and microservices architecture and all that to really scale up operations. And then you measure the, as needs increase again, you add more containers and so on. And then, because it's an incredible thing with this the container thing with Docker and system orchestration. It's really enables the expansion of use users outputs without you needing to use the old system of client servers and all those kind of things. So I think AI uses that a lot right now. Thank you. So.
Beautiful, actually, beautiful. Okay, who raised that first? I think it was Udwak that raised that first. So Udwak,
So you're asking how Tesla works. So I think I know a few things about how they work. I know that they have lots of cameras around them, and cars, they work like computers, and they use sensors and AI systems to recognize they use AI systems to recognize road patterns and the likes. That's if you know about Tesla.
Beautiful. I mean, that's awesome. That's spot on. Yeah.
I think they also use reinforcement learning, sort of.
This class is now a women in AI class. Hey, I feel threatened that as a man. Wumi, go and finish up. I'm putting the spice in there.
The spicing is threatening me. Maybe I'm saying the wrong thing.
No, you're not saying the wrong thing. That's the thing, right? No, that's the thing. You're saying the very much right thing, right? Reinforcement learning. As a matter of fact, there are some debates right now that AI should switch to reinforcement learning. That all these things we're doing about that it should be primarily driven with a reward mechanism, and that systems adapt best with reinforcement learning. But that's a discussion that we need to. Maybe we'll do. Let me not expand beyond that. Thank you, Wumi. All right, Olaloa.
Okay, so concerning on what I know concerning hardwares and maybe devices. So devices need a lower level language to interact with their components, because they can't use languages like Python with that system, because you don't need to interpret at that point. You need fast responses. So languages that can well interact with devices like Rust, like C, like C++ will be much more relevant with that device. So that means they are translating, receiving requests and all those things, and they're able to interpret it on time for that device. Then in terms of the network, I think that's one of the reasons why they built some certain cloud services with Golang, because of that high number of concurrency. But what I'm familiar with in terms of speed and performance, a lot is really going on with it. That's why language like Rust is beginning to shine in that space, because of their interaction with systems, with computer. So as much as a language can easily become numbers, binaries, the better for it. And going back to database, I just remembered. So a database will be faster if it is vectorized. Maybe you have numbers speaking. So maybe you're interacting with some tables and everything. So if you're able to index that particular column, it's faster because it's now dealing with numbers instead of characters and trying to like decode it. So that's what I think it is on my own end.
Thank you so much, Olaoluwa. At this point, I don't even know if I should continue my slide. You guys have hijacked my session. So what am I going to do now? Should I continue presenting? Because I don't know what else to say. You guys have okay. Let's carry on. I think we still have a lot to cover. All right. So when we talk about why it matters, let's sample a few case studies, right? Around what we've discussed and all that. Let's take Tesla as an example, and how Tesla has been able to leapfrog in terms of performance when it comes to real-time detection. Because again, you know that when it comes to real-time detection, the expectation of that system is beyond just speed. It is blazing speed and not sacrificing accuracy when it comes to that. So there has to be a very sweet spot, a very good balance in between speed and accuracy when such a system works. And how has Tesla been able to do this? Just like you guys rightly said, Tesla is the model Tesla car is full of cameras. Right? That's how it's able to interact with the environment and be able to identify road patterns, identify stoppage, you know, and do that. And it's not just only the cameras, right? The cameras only from one section. There are sensors around the cars for object detection, right? So the system should be able to combine all of this and then do all this at real time, and at the same time also do data offloading and data unloading. So what does that mean? The model Tesla car does data offloading, right? It uploads data to OpenAI to Tesla servers so that they can continue to increase the capability of the model. Now, when it's now done data unloading, the same model the same data that is sent off to the server is used to train a new model that is sent back into that car. So the model Tesla car is like a phone, like a mobile phone, right? There's software updates, there's model, there's airdrop of models, right, into the car, and then there's model drift being monitored, and the data drift as well being monitored. So for such kind of system, it is mission critical that every single milliseconds count. That's what that MS stands for. Every single milliseconds count, because it is the definition between accident or no accident. It is the definition between taking you from your house somewhere else. I mean, I don't know how many of us have been in your car, or you're driving and you're using Google Map and then you land somewhere else. I mean, just about last month, I was going to Ibadan and we were using Google Map. The map took us to a village. We were actually going to University of Ibadan. The map took us to the village. Google Map, precisely. We landed in a village. And the map kept telling us where we're going, which is a financial institute, is in the next bend. You go to the next bend, you see bush. The next bend, you see bush. So, you know, the difference between such working system and not a system of sort that does not work is just the thin line of a millisecond. So that's how much it is important for Tesla. Now let's look at Netflix. Netflix handles streaming in billions of bytes, right? Every single day, somebody is streaming Netflix. Somebody is watching their favorite movie of Netflix. Somebody has watched it just now. They're watching it again. I mean, these people, they deserve a special prison, right? They've watched the movie just now. They watch it again. They watch it again. In those times when they were era of DVDs and CDs, it was always, if you're always afraid to borrow such kind of people your disc, because they will watch it until the face of that disc is beyond no cleaner can rectify it, right? But Netflix has been able to maintain their infrastructure in such a way that such system. Daniel, are you saying something? Okay, if you're not, your video is actually on because I can see something like a dark background. All right. So Netflix have been able to balance this, right? To efficiently be able to allow millions of users stream on their platform, pulling videos, right? And then being able to render it on display. So you're not stuck in buffering. It's saying buffering, because what Netflix has efficiently been able to do is design very high scalable systems and very high scalable infrastructure. So when you request to watch a movie, say for example Wednesday, right? For example, and you want to watch Wednesday from somewhere like say India, right? You're not watching it from an European server. You're watching it from the closest server to India. So they understand your location. They use your location to route you, right? If the movie is not available in your region that you are in that server, and it's available in that server, they allow you watch from the farthest server where it's available. And while you're watching, they stream that movie into the closest server near you and redirect you again down there. Now, the beauty of all this is that you don't even know this is happening. You don't even feel it. To you, your video is just going so well. You're just watching it and everything just going so good. But under the hood, the server is intelligently migrating your resource or updating your resource, updating your frame rate, and keep giving you optimum live stream. So imagine that it was such a system that began from rental and then pivoted into such high digital systems. Show you how important it is that high performance systems are crucial for AI ML workloads for AI systems as well. So one last one we'll look at before we move on is TikTok. You know, TikTok has become like the facto place where people go to what's the word? Yeah, to relax. Like people go to TikTok to relax, or people go to TikToks to catch fun, right? And you find content being pushed to TikTok every single day, and their server is successfully scaling through that. And then they're also giving you personalized recommendations as well, that you're also able to see such things as well. Please give me a minute. Let me take off this call. Yeah, and Netflix and TikTok is able to scale their servers and also keep providing such services, right? So for them, it's also mission critical as well that they maintain throughput to a particular degree to ensure that their server, all right, continues to cope under such weight of new added users and continue to survive as it goes. So let's talk a bit about metrics of high performing systems. There are about 4 of them that we look at, right? But before I go on, let me ask this question. What do you guys think is the difference between latency and throughput? What do you think is the difference? You hear latency every time, latency, you hear throughput. What do you think is the difference between latency and throughput? Anyone?
I believe, I believe latency has to do with the delay in getting the consumer to the signal to the service, getting the service across to the consumer. If for example, the consumer makes a request and then the network of the consumer has a problem, or the network of the server has a problem, then the consumer would see a buffering delay in getting the answer to his request. And and I think that's gap between optimal return on speed to get request answered, and then the delay is the issue of latency, has to do with latency. Yeah, sorry, that's my view.
All right, okay. Any other person? Latency and throughput.
Yeah.
Okay.
I think latency is like in simple terms, like the time taken for a task to be completed, like how fast it can get a task to be completed. That's what latency means. So I can give an analogy of like maybe are we defining in terms of AI or just generally?
No, go as verbose as you want.
Okay, so let's say maybe the time taken for a request to be made. Let me say
the time taken for a car to travel from point A to point B. But my understanding of throughput is like, oh, okay, this particular highway, how many cars can pass through that same road at the same time? Maybe, I don't know, should I link it to parallelism or something? If I'm not going off point.
No, continue.
I'm finished.
Okay, that's good. Olaoluwa, go ahead. Thank you, Umi. Awesome.
All right. So for me, latency is has to do with a particular request, a single request. So a single request can be very fast, right? I mean MS or so, but throughput is now combination of all the requests per second. A single request by like maybe 50 ms. But by the time all those requests begins to get to like 1,000, throughput can begin to drop. Like it can begin to become larger. Maybe at the end of the day, you are now having it cannot answer, it cannot 1,000 requests per second. So that's my own idea.
Okay, great. Utman said latency is speed per request, throughput is the capacity. Nimi said latency is the time it takes to process a query, throughput is the total number of queries within a specific time. All right, so my question now is, can we achieve latency and throughput at the same time? Can we have high latency and high throughput at the same time? Sarah, can Sarah hear me now? Okay, I don't think Sarah can hear me yet. Udwak, nobody has said this one. This is a fresh question. Can we have high latency and high throughput at the same time? Is that possible?
No, I don't think it's possible because high latency implies that the speed of the performance has dropped. So high throughput implies that there are many more people accessing the service. And if performance has dropped, that means that would effectively mean the usage has also dropped, I think. So that correlation is reversed, I think.
Okay, thank you, Akin. Can you hear me?
Yes, I heard you.
All right, great. Give me your own opinion. So people are blasting the charts. All these senior gurus in systems engineering and AI.
Thank you. They've said everything.
Udak, say your own. Say your own. Don't thank me. Say your own. We're waiting for you. You're meeting your mic to join me to celebrate that somebody does not have lights in the house because you don't have lights. It's possible only if you batch queries. Yeah, it can be. So Utman, do you want to mute your mic? I want to hear what you have to say. Hello, Utman.
Hi, good evening.
Yeah, go ahead.
So I didn't quite get the question.
But you responded to the question.
Oh, I thought it was on that question. So no, I think latency and throughput can both be achieved using parallelism when CPUs or the servers are using multiple cores. The request of each can actually be faster, and also they can be achieved through load balancing through. So when the request spread across multiple servers, it can also give high throughput and high latency too, with efficient algorithms too.
Awesome, great. All right, so let's talk about memory footprints and the cost per inference, right? So you've been brought into a team, right? You brought into a team as the machine learning and AI engineer, and they want to automate their system, right? and they've told you we don't want to burn cash on servers, right? How would you in your own world, right, ensure that you bring down the cost of inference? Do you guys understand my question? How would you in your own world, we had a class there on system design. In practice, there's usually a trade-off, and ML engineers prioritize based on the application. All right, so in your own opinion, right, how would you bring down the, okay, let me start again. You've been brought into a team as an AI ML engineer to build a solution to automate their process. They don't care how you want to do it. Their major concern is you're going to use an AI model for this. Okay, let's come very close to reality. You're using an LLM for this. How would you ensure that your cost per inference is brought down to the barest minimum, and at the same time your performance of your system is high, knowing fully well that intelligent models are usually quite expensive, especially if you're loading your model locally, or even if you're going to use your model on the cloud? Do you guys understand my question now? Does anybody want to attempt that question? If nobody attempt the question, I will call your name. And I'm tempted to call Ludwak. Okay, anyway, let me call Victor. Victor, what do you think?
Yeah, hi, Samuel. So I would say in terms of cost, one way I can think of would be the right size of the model, first of all. So you would have to say, okay, for what kind of task would the model going to need to use? So, and then we use it, if a smaller model can still perform the same task. So I'll look at what kind of model we are looking at. Then secondly, it would be in terms of maybe memory. So for example, tasks that would be repeated, so in this case maybe of LLM stack that will be repeated quite often, can be saved to memory so that it doesn't always have to redo the same thing over time. So thereby would also keep the cost of inference at a minimum level. And then yeah, also maybe like, yeah, I mean for now, so let me just think about that. Yeah, for now, maybe just two things for now.
Victor, talk to us as engineers. You're talking to us like we are accountants and admin. Talk to us as engineers.
Okay. So for example, it will be more of, we first of all make the models more efficient. So that's what I mean by using smaller models where needed. So this would be like in the context of like compressing it, like a quantitization, where you ensure that only the parts that are needed are used per time. So that if for a particular task or in this case, when it's not needed, then it's not running. So it only activates what is needed per time. And we also quantize the model. Also, we can do maybe a way of caching and batching. So that's what I meant by, so for example, group similar tasks together where you reuse like past results for things that are similar. So in this case, instead of it always recalculating, for example, when you're building the LLMs, like when you build your vector database and all, yeah, you can save. I think there was, if I remember, during like the early classes, there was one of the methods of transformer models about how instead of it recalculating every time, you can actually kind of batch and cache similar requests together, so that if it comes, then it just picks from that instead of the model recalculating. So that would also save cost. And then for sure, there would be optimization in terms of like saving of the model. So in this case, run on GPUs, servers, what kind of GPUs you have to pick. Okay, depending on the task, it select. And then you're also looking at scalability, where depending on the demand, whatever AI infrastructure or system you are building, it scales up or scales down depending on how much demand is coming per time. So more scalable than just picking like, oh, maybe the largest or the smallest. Yeah. So yeah.
All right, beautiful. Anybody want to contribute to that? Give me 1 minute. I need to come back to this call. Okay, yeah, shoot.
All right. So I'm not familiar with machine learning models in production, but I have watched a couple of videos online on YouTube. I watch a lot of them, and I think one of the major things in terms of, so I'm familiar with costs for software development, but for ML, I think one of the things that will be most important is optimization. So using the right tool, production-ready tools for the job. So there are some things that are already optimized. If you're using the Python, if you're using Python, right, there are things that have been well optimized in Python. And if you're using calculation intensive, let me say, workflow, maybe functions, not building those things with Python itself, but transferring those calculations to libraries like NumPy, things that are ready-made for production, things they've already worked on. So that's going to help to optimize it's going to help to optimize latency and throughput altogether. Then memory footprint also very important in that, because if your code is running in the server and while it is running, it is consuming a lot of memory. That means you need your CPU, or sorry, your server to have a high memory. And things like tools like let me say Golang came into place. I watched a video where a guy had to transfer his rebuild a particular thing in Golang, because Golang takes 2 kilobytes per one Go routine. It's unlike Java that takes like 4 MB per that particular thing. So on the long run, Golang saves more cost. So it's about optimization for me in terms of cost.
Right. Okay. Great. All right. Thanks. Is Nimi unmuted to speak, or that's an unmute error from network? All right, Nimi, go ahead.
I don't know what's wrong with my settings. Can you hear me?
Yes, I can hear you loud and clear.
Can you hear me?
Yes, loud and clear.
Okay. So I have a question, please.
Okay.
My question is this. My response to the high latency, high throughput question, where I said it's possible if you batch queries.
Mm-hmm.
I got that while I was reading yesterday from Chip Uyen's book about the difference between ML in research and ML in production.
Mm-hmm.
But I would like if you could give a practical example so I can better understand that.
Okay, so in the case of, with respect to latency and throughput for batching queries together, such a situation would usually happen if, for example, you're doing, I don't want to use Netflix as an example. Oh, that is a perfect example now. I don't want to use Netflix, it's too common. Should I use something around? I want to pick something around data that would best explain this.
Bank transactions.
Yeah, fantastic. Bank transactions. All right. So bank transaction best explained. So let's say you have a fraud detection model, for example, right? Or let's know, even if it's not a fraud detection model, let's say you have, okay, let's use fraud detection model. That's the closest we can use. Others will be too high-end, right? Fraud detection model. So you have like transactions coming in, and the fraud model needs to predict them. All right. So instead of you to take one transaction and you're predicting one transaction by knowing fully well that majority of the time, right, most transactions hitting the servers are coming concurrently from many people at the same time, right? So such queries, you can just batch them, right? And then put them into the AI models, the AI model, or into the AI system, bring back the result out, and then you can then put inference on that. A very, 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 very unique use case for that is when you're trying to predict the probability of fraud, or try to predict transaction limits for certain users for certain user clusters, right? So if you, let's say you create a particular user cluster for politically exposed person, right? Or let's say users that are on a particular watch list, and then they perform transactions, right? So those kind of you can batch them, and then batch those, you consider them as queries terminology, right? But when you bring them to the domain, they now take different names. So let me use queries as you mentioned. So you take those queries, you batch them. So instead of to pass it one into the system, remember that if you pass them one into the system, you've created a queue, right? You can just create a batch of say 100 queries at the same time, and then batch loading into the system, the prediction comes out, and then you can then do inference on that. Does that answer your question?
So this is manual.
No, this is not manual. This is a system. You build that system, you write the code.
Okay.
Yes.
Okay, thank you very much.
All right, thank you, Akin. Yeah, that was spot on. That was spot on. Okay, let's move on. Do you know what happened? Okay, any question that comes in, you guys can just raise your hand or just unmute your mic, and you can cut me too. Don't worry, I'm cool with that. All right, so let's move on quickly, so that I can make the best use of the time. All right, let's talk about performance bottlenecks and where they actually really occur in systems, right? So you get to realize that common bottlenecks in production happen at certain stage or certain phase in the entire system, whether it's an AI system or in an AI system, but we will focus on AI systems for this, right? You find that 40% of such bottlenecks happen at the computation level, right? You find that 30% of it usually happen in the memory level, about 20% of such performance bottlenecks happen in the IO level, right, within the system, and then 10% happen with respect to network. Now, 10% with respect to network, because again, when it comes to issues around network, there is usually very little you can do as an engineer optimizing a system for performance, because you cannot go and beg the user to use good network. You cannot go and beg MTN, right? So please give them good network. You can't do that. So it's usually out of your purview for that. But when it comes to scaling your system for performance, majority of it lies in the computation level, and that covers your algorithm, right, and your hardware utilization. So once you crack it on those two levels, and the algorithm again now depends on you as the engineer. What sort of algorithm are you using, or what kind of algorithm did you build to scale your system? That's why you keep hearing from time to time server system companies are moving switching their language. I think Microsoft, was it Microsoft? Yeah, I think it was Microsoft that switched majority of their languages away from, I think, TypeScript to Golang. I think last year or something, or early this year. I can't remember that news much clearly. But you find that systems say, oh, we are migrating from this language to Rust, we're migrating from Python to Golang, we're migrating from JavaScript to Python, because again, how efficient is the algorithm and the hardware utilization of such algorithm depends on how much you can even actually do when it comes to tweaking those systems. Because from time to time, no matter how much you build the system, you always come in to iterate and try to unlock more performance for that particular system, especially as users grow. You had 100 users, you had 200 users, 500 users, you have to come in, unlock, see how you can scale, optimize this function, minimize or decouple this function, and a lot of other things that go in. So this pyramid, right, explains each of all these in all the bottlenecks that attack systems, that make them difficult to actually scale, and how you can actually make certain focus on them, right? So for memory precisely, when it comes to managing memory in especially AI workloads and AI system, it takes you down to around 3 to 4 ways you can actually look into bottlenecks in that. One of them is memory profiling. You need to understand the memory usage pattern of your system. How is your system using memory? Is it hogging memory? Is it utilizing memories or creating a lot of garbage heap, right? That is slowing down the entire process, or are there race conditions to write to memory addresses and the likes? Then you look around, how do you optimize memory in itself, right? How do you create gradient checkpoint? How do you optimize with different flow types so that you can have like mixed precision training and the likes? How do you also ensure that you are efficiently loading data, right? Because again, a good clear example is when you're trying to choose between pandas or polars when you're working with data, right? how do you make such choices? Or how do you move to PySpark? Right, because again, if you're working with data loading, especially data loading, and you're creating structured data from that, say your system takes in now this is not RAG. Not everything that involves document is RAG. So you should please let RAG rest. RAG in those days used to be dirty clothes. Now RAG is becomes so you find that when you're ingesting data in, you bring in a piece of document, and then you need to convert that document into structured data, and then load that structured data in a particular database. As your system grows, or as you bring in new users, or you onboard new businesses to your system, pandas can no longer do this for you, especially if you cannot actually put a cap to how big these documents can be. Pandas gets to a particular point where it can no longer scale, because pandas at a particular point gets boxed in because of the way it was written, by the way it can efficiently use the compute, right? So at that point in time, you now have to now switch to something that is designed to efficiently milk your compute. So if you say your system server has like 128 gigabyte of RAM, for example, it doesn't have to be that big, right? Say for example, 128 gigabyte of RAM and about 1 terabyte of ROM, right? And you're using that CPU, right, to do data loading. Or let's say you have a GPU that uses a T4 or T4 and L4, right? You need a particular library in terms of your algorithm choices now that is able to milk that resource efficiently to drive performance for your system. So if you're stuck with pandas now, in this case, it becomes a problem for you, because you find that the system cannot go beyond where it already is because of the choice of technology or the choice of library that is being used there. All right. So how it is able to perform efficient data loading and data unloading is a big plus. Then you now come into memory cleanup strategies when it comes to memory management. Like how do you clean up memory to ensure that memory is freed up? Especially if you're using a GPU, how do you ensure that your data loading strategy is unique, not just unique, but is excellent, right? So that you don't load into memory and load into memory and load into memory, something you should have loaded into memory just one time and reuse. So such concept is called creating or warming up a model into memory addresses. Right? So you warm a model in. When the model is warm, you begin to use it. So you're not just creating multiple memory addresses. It's what typically runs into the popular OOM, out of memory error, that occurs with PyTorch, right? Where you have like a T4 that gives you 15.6 thereabout gig of GPU RAM, and then you bring in a model. Let's say you bring in Gwen 4B, and then you load Gwen 4B in there. The T4 is already sloppy, about to enter coma. And then after doing that, you run inference, then you reload it again. The entire infrastructure will just collapse. Right? So memory management is really, really critical, just as important as you have your algorithm choices and how you're able to efficiently handle or utilize your hardware. Okay, so let's expand a bit on hardware. I think I touched around some of these, but just a little bit of expansion again. All right, so your hardware actually, for high performance AI, your hardware actually utilizes each and every one of these on the best level, right? Where you have like a GPU that allows you to go on general purpose and cannot really do so much in parallelism. And then you have like a GPUs that's designed heavily to expand on parallelism and the likes. And then you hedge accelerators that are small and power efficient. All right. So before I move on, I want to ask a general question, and then let me hear what you guys think. I mean, this is a room of engineers in AI and machine learning. Whether you are like, was it not Nimi that said that? No, who said that? That said they are here. I think it was Wumi that said she gave public declaration and said she's not an engineer, but she's in an engineering meeting. We need to take her outside and baptize her specially. So you get to realize that in terms of efficient utilization of systems, most organizations are pushing for edge acceleration, right? So what do you guys think? let's put it into two perspectives, right? And I think you can pick anyone you want to answer from. So there are like two questions. You can pick anyone you want to answer from. Interesting. There's two parts, so you have to pick the one you want to answer from. So the first part is, do you think small language models, let's use language model now, small language model is efficient to drive enterprise products at scale? Now, when I say efficient, we're discussing performance in AI. So do you think small language model is efficient in terms of performance now, right, to drive enterprise product at scale? So let's say we're using a small language model and we're onboarding more users. You know, what that means is that users will now have a very wide variance in terms of questions that users can ask, which means there's now workload on the model to be able to perform and the likes. Then that's one part of the question. I hope you guys understand that. So the other part of the question is, do you think having many small language models in a product that performs specialized tasks is efficient enough to provide effective performance in that AI system? All right, so pick any of these two and just answer.
Yeah, so I believe that a small language model would not be able to scale productively, efficiently in an enterprise setting. It would lead to high latency because due to the size of the model, requests coming in, it would be overwhelmed with trying to attend to those requests, and will be swamped easily, and which would lead to high latency. And then, yeah, that's my view for the first question. If a small language model would work for a large enterprise solution, you know, I don't think so. I think it would lead to inefficient allocation of resources and then definitely increased latency and lower throughput.
All right, anybody else?
Yeah, I want to say something to that. So I think it really depends on the task. So the first question about are small models, for example, scalable for production ready or enterprise? I would say yes, if it depends on the task. For example, if it's in a narrow or like a routine task, maybe for example, customer support or something that is quite narrow, then it's very possible that the small language model will be scalable, because in that case also low latency and of course cost, like we were talking about. But I think also then if we are looking at the second question, can many small models, you know, work versus maybe in this case one big model? I think that's also possible, but again, it would be like perhaps if you have multiple uh, task, and then I think you have to check the performance. So in the case of, you have to test like, okay, if I use small models versus one large model, how does it work for you in terms of your cost, in terms of the latency and everything, and see. And the difficulty that I see with me language small LLM or small language models in this case would be how to orchestrate everything. So that would be one of the challenges, like how do you orchestrate everything, or how would you route tasks to each of them? But overall, I think both can work, but depending on your use case.
Okay, all right. I need everyone to attempt this. I want everyone to attempt this. If you don't attempt, I'm going to call your name. Chirag, I've been calling Chirag. I don't think they can hear me. Ajay, can you hear me? Okay, I don't think Ajay can hear me. Utman, what do you think? Everybody, both are women in AI that have stolen the show earlier. Everybody is going to, I want to hear what you have to think about this. And I will ask follow-up questions. Utman, can you hear me?
Aye.
All right, good.
So I think the other guy said what I actually
No,
want to say.
no. The other guy cannot see what you are. You Utwak?
Oh, sorry. I thought you said Utman.
Yes, I called Utman, but the other guy cannot see what you have said. That's Utwak's favorite statement. So that cannot be your statement.
What I actually want to say is, I think it depends on the use case. So, smaller LLMs are like kind of like faster and cheaper. They actually require less CPU or GPU to work. So the smaller LLM depends on the use case. If the use case is just about the customer support or small workflow automations, I think the smaller LLMs they respond faster than and I think they work in a enterprise in a enterprise.
Okay, so Utman, is that to answer question 1 or question 2?
The question 1.
Question 1. All right. So now my next question to you is: so you built this, right? For example, you built this system, and then you now have the company now says they want to outsource this as a product to other companies, which means other companies will now connect using maybe an API or a webhook or something to integrate this in their own website or their own platforms. Now that means that initially, when you used your small language model for your company that employed you, you were serving the user base of your company, right?
Yes.
Now your company now makes it a product for 5 other companies. So your company had like 10,000 users. No, okay, that's too much. I had like 6,000 users. The other companies had like 2,000, 3,000, 7,000 users. That's together coming in now is 12,000 users to your existing 6,000 users. That's 21,000 users. Do you think the small language model will be efficient for this kind of enterprise AI scale? Bearing in mind that 12,000 users are going to ask different things at the same time. Somebody might supposed to ask, they're supposed to ask, what is my refund? They will just ask something else entirely. They're trying to say refund, but they're now extremely ambiguous. So what do you think?
I think the smaller LLM might not work for the use case.
So how do you remove that bottleneck?
I think to either add either you horizontally scale it or you vertically scale it. So you can add other smaller LLMs together with it, or you switch to a larger LLM.
Okay, so when you scale it, when you say scaling, is it vertical or horizontal?
You can actually try any of the two. You can scale it.
Usman, don't give us politician answer. Don't give us a political answer. Okay. You are an engineer. You're not the CEO. What are we going to do?
Let's go with we can switch to a larger LLM.
I need somebody to agree with Usman or disagree with him outrightly. In a we no go agree style.
I think the other guy, there's somebody, I think not Solomon, somebody else said something about the orchestration of multiple small LLMs will become a problem at scale. And I think that will be the hindering factor to efficiently build them out, use them for bigger operations. If you have multiple small language models, and then you want to keep increasing, going, like you say, if you expand horizontally, as in you expand with more smaller ones to keep doing more and more things, you come to orchestrating them will become a problem, and there'll be bottlenecks, systemic bottlenecks in different places. But if you have a single vertical expansion going up with a larger language model, the larger language model would have the capacity to efficiently scale massive requests. I think that's just my view. It's all the same.
Are you agreeing with Utman or disagreeing with Utman? Are you a rebel leader or you are for the cause?
I believe Usman was on this. We're on the same page.
Akin, are you for Utman or against Utman?
I'm with Utman. He's saying the same thing effectively. I believe we're saying the same thing. Orchestration to me is a problem for small language models, which would really make them very inefficient at scale. You know, if you're using multiple of them at scale.
Okay, Kingsley's laughing. Kingsley, tell us what's funny. Maybe the small language model are models that are designed to make us to relieve stress. They're therapist models. Kingsley, please tell us.
Yeah, can you hear me?
Yes, loud and clear.
Okay. Yeah, I think what I think is that the best way that we should go is first of all to like improve our system infrastructure to like taking more requests. Then coming to the models, what I think is that if we can like deploy the small language models
Sorry, are you answering question 1 or question 2?
I'm answering question 2.
You are laughing. That's how to pick the one you are answering. But you pick one.
Yeah, I'm answering for question 1. I think the small LLM can be efficient for enterprise use case, in the sense that they can be fine-tuned for a particular use case. So instead of deploying large models to the cloud, that would like, incur much cost and processing and the rest. So it's better to like have a fine-tuned one for enterprise use case that would be faster and save money. Then yeah.
Then what? Then no, go ahead. Then what?
Then for the specialized LLM for different enterprise use case. So I think that for some reason, I think what we can do there is that we can actually deploy the small language models to like serve different clients or different use case, different people that will need it. But if the request grows too much, or maybe the user base keeps increasing, might have to like go for a larger model.
Okay. All right. Great. All right. Udwak, come and stand in the center with the mic. Question 1 or question 2? Don't worry, Mimi has laughed. She's going to follow you as your deputy. Don't worry yourself.
I think Victor answered question 1 already.
He did not answer it. Nobody answered any of the questions.
Okay. No, I can find I flow with what he's saying. So I think I'll just go with question.
What flow did you flow? You are flowing, you know. We are not even flowing yet. We are trying to flow. Give us your flow. Let us flow with it.
Okay, for the first one, I agree with what Victor said. Okay, no, I'll say
you agree with what Victor. Don't agree. We don't want you to agree. Don't agree. It's okay to disagree at this point. We are fine with that. What is your own opinion? You must have your own opinion.
Okay. For small language models, I think they'll definitely be efficient for enterprise scale AI system, depending on the tasks. If they are just lightweight tasks, it might be efficient. And then, like, let me just speak from experience, little experience that I have. Please. Some little experience I have. Like, of recent, we worked on. There's a platform that was just to process data and visualize it. Like, it needed to be automated, you get. And then they were using big tools, Databricks, Plotly, and the likes. Like, I felt like there was no need. And all those tools were quite expensive, and the company couldn't pay for all of that. Do you get? Like, I feel like we're able to use free source, like cheaper ones compared to those ones, because the tasks were just lightweight tasks, data processing and just visualization. Do you get? Then for the second one, do I think many specialized yes, I feel yes, second one is, I go with it. Yes, I think so. Like the small the models have their own different taxes. Like they have their own different jobs they are doing, and I feel like low latency and the like. So it goes.
What goes?
Yes, lower cost. Since they are small models now, they tend to they perform better. They have individual tax. Like they're just doing individual tax, despite the fact that it's an enterprise scale system. You just give them individual tax to run. They are faster at this point.
All right, Nimi, go ahead. Thank you, Uduak. That your opinion was very insightful. Nimi, go ahead. What do you think?
I don't have an opinion, no. I'm just listening to everyone.
But you were laughing.
Okay.
But you were laughing. So how can you laugh and not have an opinion? If you're laughing, it means you had an opinion that was funny.
No, she hadn't spoken. It was what you said that was funny. So
Okay, so now that you have the mic, tell us, give us something. You know, Uduak once said that she doesn't have anything to say, but then she started telling us about a project that she worked on, that they were using big tools in the industry. Right. So
she has experience. I don't have experience.
that's what she
Focus
said
of
earlier, that she
knowledge.
doesn't have experience. Then we realized that she has worked with big boys in the industry. So please.
Yeah. Truly, I have no idea.
Okay, we'll circle back to you. Oluwapemi, what do you think? Then after that, you can go to Olawumi. And then I've not heard Daniel's voice this while. So not Daniel Bitayo, Daniel Okpara. They will move down to Daniel Bitayo. What do you think?
Okay, from my end as well, I have no idea. Just gonna listen and leave.
Are you guys creating a committee of no ideas?
No.
That can't work here. Okay. Yeah, Daniel Okpara, what do you think?
Hello?
Yeah, I'm with you.
Oh, okay. Well, I'll speak to the first question.
Okay.
I think special, I don't know, sorry, small language models will be efficient for enterprise scale AI systems. Why? Because now you can, since the AI, that's the SLM behind it is small, so it can be specific to a task, right? So it can be a range of tasks, but they are not so large, so you can make them more specific to do some specific kind of tasks, right? And you can have many of them, so you can have a lot of those kind of SLMs doing specific things, which can all boil down to like, so when you combine, when you have those specific tasks being done by specific tasks being carried out by these models, you can have, and since you can replicate that kind of system, you can replicate it, you can have a lot of them doing specific things, then those they can all comprise to be an enterprise, if that makes any sense, right? So I think you can achieve efficiency when you have certain specific tasks that are assigned to these small language models.
That's interesting.
Yeah, that's my take.
All right, that's really interesting. Okay. All right, let's move on. I think that question was just deliberately to spark conversations. Yeah, so when we talk about trade-off, right, there's always a trade-off. And the trade-off triangle looks something like this, where you have to look around accuracy, speed, and cost, and then find that spot in between where everything works, right? Because again, every company want to use the best model, but they're afraid of cost. Every company want to use the better model, but they don't want to sacrifice for speed or accuracy. So as an engineer designing for scale, right, the first thing that should come to your mind is how do you ensure that your system is smart enough and is empowered enough to be able to cater for any of all these triads. So really, how do we measure performance when it comes to building AI systems? There are a lot of there are some awesome tool out there that allow you to actually measure performance. Because again, high performance in AI is about impact at scale when you think about it, right? A model that is great in your notebook might fail in production if it is too slow or if it is too expensive, especially to run and iterate. So when you think about it, profiling is that diagnostic step in performing systems, right? Is that diagnostic step that you need to know before I bring this to production, what's slowing down the latency, how potential, what's the potential for this to experience good throughput? All right. So what's increasing the latency rather? Because you want to bring that down. As I said in the chat, there's inverse relationship between the latency and throughput. All right. Okay, so a bit of touch on data parallelism, but what I'm going to do is we're going to discuss around this, and then in the coming sessions we will expand and do a much more deep dive. So when we talk about parallelism, we can think of parallelism on 3 legs: data parallelism, model parallelism, and pipeline parallelism. Now, pipeline parallelism is basically you, right? More you than even the system. Data parallelism is all about how you now as an engineer is able. Can you guys see my screen? Okay, good. I think you can see my screen. So data parallelism is about how you as an engineer is able to ensure that your data is batched, either pre-training or post-training. All right, because again, you're targeting a system that is so high in efficiency, right? So high in efficiency and performing in speed. So, and again, you understand that the backbone of every system or any efficient system is data in, data out, right? Data in. Once you crack that code, that it's basically just data in, data out. You become much more focused on how efficiently you want to ensure that data is batched as it come in and as it come out, and keep the thread going. All right. Then okay, let's move this to the session. So let's just have a round discussion around model and inference optimization techniques. So there are a lot of there are different techniques that you can look around when it comes to model inference, model optimization. All right. And then there's also some that you can look at when it comes to inference optimization. All right. So for inference optimization, let me start with inference optimization. There's batch processing. All right. There's how you serve a model. When you convert your model to either TensorFlow or ONX, or you use TensorRT, are your different caching strategy. I think Olaoluwa mentioned something around that, your different caching strategy as well. And then if you're deploying for edge, that is on a particular device, not on the server, how do you ensure that you combat edge computing constraint? How do you ensure that your system is well optimized for mobile deployment and the likes? All right, I said to talk about model optimization last because I want us to have another discussion about model optimization. You know, there's always this particular notion around that when you optimize a model, it kind of loses some very good part of itself. So how many of us have actually said you've quantized the model? I said, if you quantized the model before, say you have a large model, then you quantized it. Or okay, have you used the quantized model before? GGUF and the likes? Nobody? I don't want to believe that. Nobody has used a quantized model before. Okay, that's interesting. So please make that an action, right? There are a lot of quantized model on Hugging Face that you can use, right? Quantized model are actually models that have been minimized, right? Some layers have been removed to reduce the size of it, so you can load on less intensive systems. Say you can load it, you can load as low as on a CPU, right? So you can load on a T4 and the likes.
Okay,
This is something.
DeepSeek, yeah, DeepSeek. When it came out, one of the attractions that the Chinese ran was that it would load on your CPUs. DeepSeek 1.0, and it was quantized. You're right. That's a lot of people used it then. Well, we know, but I think a lot of people do not know that it was quantized. Now you're explaining it. It now comes out that okay, that's what it means.
Yeah, thank you, Akin. So it's a good thing that you yourself can go ahead and play around with it, guys. Ensure you don't only just hear these things, you also have done, or you've gotten your fingers or your legs and hands wet around them, because it gives you that level of exposure that you actually need to actually scale through. Okay, so I'm going to draw the curtain for my session tonight here. All right, and then open the floor to entertain more questions on the fundamentals of high performance AI. Nimi, wait. I didn't say you should clap yet. Udwak is clapping. Somebody that said she doesn't have anything to say. What other people have said is what she has said. She's clapping. Okay. Udwak, why are you clapping? Are you clapping because I've said what you want to say? Udwak, I can't say what you have said because I'm the one with the slide. All right, any question, guys? Do you have any question? Okay, Olaoluwa, go ahead.
All right, thank you so much. I know there have been classes before I came, but I think I'm still right on time to ask this question in this period. So in terms of machine learning, production, and the likes, how far can cost go? So why I'm asking this question is because if I'm giving my organization that confidence that okay, we can deploy this model, how wrong can I be in terms of by the time we go live, and how wrong can I be in terms of cost at the end of the day, and then I begin to see that the cost is going way too high than I predicted. So I hope you understand my question.
Yes, I understand your question very well, because I've been in a similar situation whereby when we were done with the experimentation, we saw a bill of 2 million naira from Google. Everybody was shocked, right? We saw a bill of 2 million naira from Google, and everybody was like, how did we get here? So your question is actually very genuine and very realistic. So learning from my own experience, what I always say is that start with a pay as you go AI service. That start with API AIs. Always start with API AIs. Always start with API AIs. Don't start with loading your own open source. It's a very bad way to start, except it's absolutely, that is in terms of, now we're talking about reasoning models like large language models. But if we're talking about machine learning models, right, that you can easily load on a CPU, you really don't have any problem, right? You don't have any problem again. And another rule of thumb is to always, as much as possible, use an on-demand server. Like on GCP, you have Cloud Run. On AWS, I think it's App Runner. Can't remember again. I think it's App Runner. Right, on Azure, I think it's container something. But always use a service that is on demand, so that when nobody's using it, it can scale itself and save cost, and when they are using it, it can wake itself back up. Right, but how wrong can you be? To minimize the propensity or the tendency to be wrong, it's always good to start with what you can control. And that's why I say, if in this era of LLMs, use OpenAI, Grok, or Anthropic, or Gemini, that you know that is a pay as you go, and then cost can easily be managed. You don't need a GPU yet unless it is absolutely necessary. And if it is absolutely necessary, ensure that you start with a very small version, say a T4, a single T4, and then you have like an estimation, because the providers already give you an estimated bill of what to expect, right? So you already know the estimated bill of what to expect for your T4. So the way they price servers these days, some follow a particular pattern, some are dynamic, some do it based on the number of requests that comes in, they charge based on that, but some charge on a statutory fee, and say irrespective of the request, because no matter how your request comes in, your server will have a limit, which means you must buy new servers. So again, like I'm going to reiterate and say, you ensure that you start lean, do the math, because each server always give you a projected invoice cost of what you expect, and let it be very visible to the stakeholders that we're embarking on this project. This is the server cost. It's going to cost us $200 or $500 per month. We're going to run this project POC for 4 months. That's roughly $800 plus minus $1,000. That's the total expense to do a 4 months POC for this particular project. Ensure that there is buy-in and there's a commitment, so that nothing's going to come back and say, we did it, we are burning cash, he didn't tell you, he didn't tell anybody, and things like that. Does that answer your question, Olalowa?
Yes, it perfectly answers, and even more.
Right.
Thank you so much.
Thank you. All right, any question? Any question, guys? I didn't hear. Udak, wow. Udak, go ahead.
Thank you. I have 2 questions.
It's 2. Wonderful.
Wait. First of all, the question you asked us, if we can you see?
Yeah, I can hear you now. I lost you at if we.
Yeah, the question you asked, if small models will be efficient for large enterprise AI. Yes. Let's start with that first, and then that will
provide the answer to that question.
Yes, that's when the answer to that question will now lead to my second question.
To your second question.
Yes.
Okay, so let's go back to the question. All right, so small language models will not be efficient for enterprise scale AI systems. And the reason is very simple. Once the discussion moves from AI system to enterprise scale AI systems, it means that the projection of what could go, the risk of what could go wrong has just increased by a very high percentage. And I try to chip this in to make you guys understand, so you can steer your answers to the question. Once a solution moves to enterprise scale, it means that the offering, the number of users that are going to now interact with that particular AI system has grown and will continue to grow at an unprecedented rate. Could be geometrically, could be exponentially, we don't really know. It could be arithmetically, we don't really know. We just know that it's going to grow and at a rate we cannot even control. So that means that such small language model, with the limitation of its reasoning, will be faced with different questions that will come from ambiguous backgrounds. Somebody might even come and ask it in Yoruba, or ask it in Igbo, or in Efik, or in Ibibio, right? Something that was designed for English. And then they will write bad review and say this solution does not work. But when you go back and you check the log, say, why are you asking this solution a question when it is an English app? So it's an enterprise. Once you move to enterprise scale, you can no longer rely on small language models. You're already about to run into problems. That answers A. Now that takes us to B. Do you think many specialized SLMs will be performance efficient for enterprise scale. Now, this question is a probabilistic question. It is a yes. It can be a yes. It can be a no. It is a yes if those specialized models are for specialized domains. So let's say we design an application to assist doctors. You know that doctors will not come and ask it about their son's birthday. It is designed to help you in your day-to-day work in attending to patients. It is not your personal assistant. It is your medical assistant. So it's a specialized SLM for doctors. And there are many of it. So there's for doctors, there's for accountants, there's for this, there's for that. So when you put that at scale, yes, it will scale. Now, the part of the no part of it is that how large, again, are we scaling this? How large are we scaling this? Are we scaling this into a doctors? No, when we say doctors now, there's specialized field in doctors, right? In medicine, there's a neurosurgeon, there is this, there is cardiac, there's a lot, right? So that small language model, remember I said small language model, which means again the reasoning for that model is capped to a particular degree. It's not general purpose language model that has been trained on large corpus of data sets. It's been trained on a very subsection of data, a particular data set, which means that if it does not understand or has not been exposed to data set on, say, on what are children doctors called again? Pediatrician, exactly. So if it has not been exposed to pediatrics in medicine, right, it will respond based. If you ask a question on pediatrics, it's going to be lost, right? It will know what to do. So that's why I said that question is a yes and a no, because it now depends on what's the interface for that enterprise scale AI system. Are we good, Udrak?
Yeah, secondly, so what if you're not so sure of the number of users? Is it not advisable to start small?
Yes, it's advisable to start small. Are you referring to question 1 or question 2?
Like, let me say, for instance, you're not, you have to build a system where, okay, to be very practical, you have to build a system, should I say like a matchmaking system? Do you get?
Mm-hmm.
And you're not sure, you're not so sure if you are going to have so many users coming into that plan. Do you get? So at that point, you're like, maybe you should build small, and then at some point when you realize that, oh, you're not having so many users, then you can now probably optimize your system.
Okay, I agree on building small, but not small on the reasoning part, small on the system part, the server part, the infrastructure part. But if you want to give people value to come to your system, you have to ensure that the value is driven from a need perspective. If you bring a small language model to do matchmaking, right, you understand that people want to first interact with it. They won't just get matched like that. They want the model will need to understand their interest, understand their life, understand their profile, understand everything about them, right? And that's why general purpose model are very good for that, because those general purpose model have been exposed to a subset of the facet of life based on what has been copied from the internet. Small language models have not been exposed to that, right? They do not have enough dense layers in themselves to be able to adequately hold large weights of data so that they can look through it before making a decision. So which means that it's like taking somebody who is in who is in year 1 in the university and then take them to take an exam for year 4. That's even too close. Let's take somebody who is in GSS2 and you take them to the university to take the 3rd semester exam for a year 4 student. The goal of the year 4 of the exam for year 4 student is that year 4 student has gone through GSS2, GSS3, down to SS, down to year 1. At year 1, the person has already started learning what they are going to write the exam for in year 4. So, but for that person, in GSS going to write the exam, they have no idea. And that's where hallucination now comes in. The model now start giving bad advice, start giving wrong advice, start saying out of points, and it comes back to hurt the product. So yes, I agree with you. Small, start small, but not on the value level. Start small on the infrastructure level. Start small on the server level, right? But then on value, you can't compromise on that. Good. All right, thank you. Any other question, guys? All right, so if there are none other questions, thank you so much for tonight. It was really a pleasure and an honor at the same time to have to speak to you guys again. And I wish you the best and a wonderful weekend as well. Cheers.